to talk through this afternoon. Enjoy.
Hello. So I'm here to talk about DRBD and its abuse for low downtime multi-terabyte database migrations. I'd like to tell you more or less what Nathan just told you. I'm a sysadmin at Anchor. I work with Jay, who was just in here talking about containers before lunch. And I'm an occasional open source contributor, mostly bug fixes and so forth, but I'm mainly a sysadmin. Okay, I'm not going to assume people know about the technologies that I'm talking about, so I'm going to give a brief introduction first. First of all, DRBD stands for Distributed Replicated Block Device. It's basically RAID 1 across a network, operates over TCP, and DRBD 8, which is the current stable release, only lets you replicate between two nodes. DRBD 9 is going to let you do more interesting things with multiple nodes, but it's not stable yet, so it's not really relevant to production usage. And it supports both synchronous and asynchronous replication, so you can either have writes need to go to both nodes before you actually get a successful write back, or you can have the write to the remote node go asynchronously in the background. What is Pacemaker? It's not that central to the talk, but I'll talk about it anyway. It's a high availability cluster resource manager. It handles the stopping and starting of resources on a cluster according to whatever policy the sysadmin defines. And it's also responsible for fencing in a cluster where you're using Pacemaker. What is Pacona? Pacona is a relational database server based on MySQL. It's what we happen to be using in this case. It's not that important to the procedure. The procedure is using DRBD, so it'll use anything that I've put down here which sources started on a file system. Technically, all you really need is a block device, but most block devices will have file systems. And it has built-in support for replication, which uses binary logging to write down the changes it needs to make on disk in order to replicate them. And I bring this up because I'm going to talk about why we looked at that as a possible solution for our problem and why it wasn't appropriate. So having talked about the technologies in use, the problem we're facing is, to begin with, we were managing a very large, about 3 terabyte Pacona server instance on a two-node HA cluster with DRBD and Pacemaker. The Pacona data was, of course, on a volume which DRBD was replicating. The problem that we found was the Pacona database was rapidly approaching the storage capacity of the hardware, which couldn't be extended because it was already full of disks. And so we'd obtained a new pair of machines for a replacement cluster, got Pacemaker and DRBD set up there, and the rest of this talk is going to be about the way that we came up with to move the data from the old cluster onto the new cluster. Okay, so the obvious solution to this would be to use Pacona's built-in replication. Unfortunately, we had tried to do Pacona replication a few months prior as a means for doing backups. It turns out that due to the very heavy write activity on this particular server instance, if you enable binary logging to do replication, what binary logging effectively does is, in addition to writing the data out to the database itself, it keeps a log of it on disk. And adding that additional write for each query that needs to be replicated slowed down performance to the point where it was not usable because we had so many writes hitting the server. So we already knew from the outset that Pacona replication was not going to work because we couldn't turn on binary logging that was necessary for it. So we thought, we're using DRBD already for data replication within the cluster. Can we leverage DRBD to transport the data from one cluster to another? DRBD is integrated into the Linux I/O stack, so writes don't, unlike with Pacona replication where the writes need to be logged separately for replication, DRBD gets the write, writes it to disk, and also writes it across a network. So there's less I/O activity required to replicate that data. There is still some additional I/O since it needs, for the initial sync, it will need to read from the disk, but nowhere near as much as with Pacona replication. And so the initial plan we came up with was, we have a pair of HA nodes in the cluster. Let's break that DRBD link and then form a new DRBD link between the node running Pacona and the new Pacona master to migrate the data, which would have worked. But the issue with doing that is with a 3 terabyte data set, the initial sync for your data takes quite a long time. If we'd broken the HA link in order to start the replication in that manner, we would have gone more than a week without HA once you add up the initial data sync to the new cluster, doing testing to make sure that things aren't going to explode when you actually cut over. And then once you have cut over, you then need to do an initial sync to the standby node of the new cluster. And once you add all that up, it adds up to more than a week without high availability. And part of the service that was being provided was high availability Pacona. So we couldn't do that because we couldn't justify having more than a week with no HA during the migration. So what we wanted to do was come up with a solution based on this idea, but that allowed us to preserve high availability for as much time as possible. At which point I turned to the DRBD user's guide, which is very complete and has a lot of information on how to use DRBD. And one of the things it suggests is using stacked DRBD, where you have multiple. As I said before, DRBD 8 can only replicate between a pair of nodes. So if you want replication between more than 2 nodes, you need a DRBD resource and then another one stacked on top of it. And the documentation describes quite clearly how you can do this with 4 nodes, which is what we had, 2 nodes of 2 clusters each. But the use cases in the user's guide were not quite the same as ours. So this provided a starting point for us. And this diagram illustrates how stacked DRBD works. The intent here is that you have the 2 lower-level resources that you can have master-slave either way. And then if you, say you wanted to fail over cluster 1 so that the left-hand node was the master, the stacked resource on top would then replicate from that. And then you read directly from the block device exposed by the stacked resource. And that would actually have done what we wanted because it replicates data from one master to 3 other nodes. That would have worked for our use case. With the caveat that because it requires stacking another resource on top of the existing one, as you will note, the resource in cluster 1, which is what we had to start with, would need another resource stacked on top of it. We would have needed to unmount Pacona's file system, which requires a Pacona restart in order to stack that resource on top. That takes a few minutes with a 3 terabyte data set, and we wanted to try and minimize downtime as much as possible. So I wanted to look for a solution that would let us effectively do what stacked DRBD is doing, but not require us to restart Pacona until we actually need to cut over. And so I came up with an idea that I've called daisy-chained DRBD, which is, on the surface, appears to be similar to stacked DRBD. It would allow us to keep running, keep Pacona running right up until cutover, and that's more or less what it looks like. So because the DRBD resource on cluster 1 is now at the top of the stack. Sorry, I should probably explain how the data is moving through these diagrams. What I'm basically...
Stephen, so on that, if you can just get into that. I'm a bit naive about how the data moves between the 2 nodes in the original HA, just as you've currently got it set up. So
yeah, I'll just take a step back and explain that. So the question was how the data moves between the nodes in the original HA. So basically what DRBD does is it's a layer in the Linux I/O stack. It exposes a block device in dev, so you have dev DRBD 0 or whatever. You write to that, and DRBD says, okay, I've got some data. I'm going to both write that to my local disk and then send that over a TCP connection to the other node in the cluster, which also writes that to its disk.
So when you're saying that you had a Pacona HA cluster, that already used DRBD to
Yes.
provide the replication? Okay.
One of the most common ways of explaining DRBD is RAID 1 over the LAN.
Yeah. I saw that, it just wasn't apparent. I come from an Oracle background, and so we just have the instances do that directly. It's just
Yeah, this is at the file system level. So no matter what application on file, the data is all replicated, regardless of application.
Okay, so the way I've got this represented here is that the data gets written in from the top, and this is basically a representation of the I/O stack. So where you have a DRBD resource above another one, data gets written to the uppermost one first, and then on its way to disk passes through the lower layer of DRBD. So you can think of this as being kind of like a waterfall of disk writes. It starts out on top and cascades down towards the right. Whereas with stacked DRBD, you kind of have it cascading down in both directions. And the reason this was suitable, this was the best fit for us, is because the resource that is on top is the one we're already using. So we didn't need to make any changes to the existing Pacona master that's running Pacona. It can just keep sitting there running Pacona while we're doing all this migration work in the background, and thus not need to take the server down.
I have a quick question, if you don't mind. Back up a little bit. Which of those are synchronous and which are asynchronous of those errors?
Okay, the way we used it, the left and right-hand ones are synchronous, and the middle one is asynchronous. I'm going to talk about how we implemented it for a specific case later.
Thank you.
So, because they seem quite similar on the surface, I want to explain what I think the major defining differences are between these techniques. So to begin with, a stacked configuration has all resources configured on all nodes. And the reason for that is because because cluster 1's lower DRBD resource can flip around so that the left-hand node is the master, every node needs to know that one or the other of those cluster 1 nodes, whichever one's the master for the lower resource, is then going to be the master for the upper one. Whereas with daisy-chained DRBD, you don't actually have it flipping back and forth in that fashion. You're never going to be moving the master for the lower resource there across to the left. So that left-hand node, which is the one running Pacona, doesn't need its DRBD configuration changed at all. It doesn't need to know or care about the fact that you're chaining additional resources onto it later. And this ties into the second major difference, which is that stacked DRBD assumes that you want to keep every single node in sync regardless of which one is the master. No matter which one of these 4 nodes is the master node at any given point, because the link connecting the 2 clusters is the one on top, any writes are going to propagate across to both clusters, regardless of whether something in cluster 1 is the master or something in cluster 2 is the master. So this is a solution that is intended if you effectively have a cluster of 4 machines rather than 2 clusters of 2 machines. So you can keep them all in sync. However, with daisy chaining DRBD resources together, the only thing you really want is data flow in one direction. You want to get data from cluster 1 to cluster 2, and you never actually care about having data written onto cluster 2, making it back to cluster 1, because we're going to eventually then migrate to the new cluster, and cluster 1 is going to be forgotten about. So they have very different use cases, and although they are similar in implementation, I don't think there's likely to be a lot of overlap in when they would be used. Okay, so before I talk about how we actually implemented this, I just want to take a moment to talk about a few other considerations we had to make. We wanted to make sure that Pacemaker and Puppet, what we use for config management, aren't making any changes at the same time people are making changes. If you start making changes to Pacemaker managed resources manually while Pacemaker thinks it's managing them, it will rightfully get quite angry with you because it's supposed to keep the cluster in a known consistent state. That's what it's there for. And if you make that state inconsistent with what Pacemaker thinks, it will try and change it. When you know what you're doing and you know that you're making changes that you want to be around, you want to tell Pacemaker, please go into maintenance mode, don't do anything. And similarly with Puppet if you're changing config files. So that's more kind of general wisdom if you're doing anything on HA clusters, but it's particularly important when you're adding new resources like new DRBD resources that the cluster doesn't even know about.
Stephen, did you find out that the hard way?
Not in this particular case. Maybe when I was playing with this stuff ages ago, but when I was doing this, I knew that Pacemaker would complain if I tried to take down the DRBD resource on the slave. So the way DRBD does metadata, which is important for how we implemented it so that it didn't cause us a whole bunch of headaches, is you can do DRBD metadata in one of two ways. You can have it use internal metadata, where you say this is the device that I want you to replicate, and DRBD will reserve a section at the end of the device where it puts all its metadata, and what you get replicated is the remainder of that device that's actually slightly smaller than what you gave it. Or you can use external metadata where you tell it, here's a device to replicate, here's a device for metadata, and it'll put all its metadata over there and only replicate that one device. So we typically use internal metadata for DRBD resources within clusters. So we did this as normal for the new cluster that we provisioned. So on that diagram with cluster 1 and cluster 2, both the internal links have internal metadata, but we made it slightly larger. We made the new cluster's volume slightly larger than the old one. The reason for this is, actually I have a diagram here that shows quite well. The reason for this is that to any lower layer in the DRBD chain, the metadata of the internal metadata of an upper layer is just data. So what you have at the top is a file system that MySQL or Pacona is using. And then cluster 1's DRBD has its internal metadata. That's what we started with. We then wanted to push that down onto cluster 2. There's no way to do that unless there's something weird you could do with device mapper to make it show a smaller device or something. There's no real way that you can do that without also replicating cluster 1's metadata, but that's no big deal because it's a fairly small part of the disk. So we had to make cluster 2's volume larger so that it can accommodate both sets of metadata, only one of which it's actually using. We then configured a new DRBD resource between the old and new clusters. For that, we used asynchronous replication, the reason being that if something went terribly, terribly wrong in the new cluster, which is not in production, we don't really care, and we don't want it to affect what's going on in the old cluster at all. And we use external metadata because we were layering cluster 1's original DRBD on top of the intercluster DRBD. We wanted the device that it exposed to have that metadata in the correct place. And the two ways we could have done that are to calculate precisely the size that DRBD is going to use for internal metadata, which is finicky, and I didn't really want to do that. Or tell it just use external metadata, and then you get exactly the same device out on top as you have underneath. And then the original DRBD can continue synchronizing as normal. So given that plan for how we do metadata, we first had to temporarily bring down the DRBD slave on the old cluster so we could insert a new layer underneath it. This comes back to what I was saying about restarting Pacona. Because we were layering a new DRBD resource underneath it, we could do it on the slave, as opposed to if we were doing stacked DRBD and putting the new resource on top, we would have to restart Pacona to get that to work. We had a resultant loss of HA for about 30 seconds. It's a few commands to bring down the resource, bring up the new one, and then bring up the existing one on a new backing store. And then we could re-enable Pacemaker on the old cluster, and it might seem non-obvious why, but Pacemaker doesn't really care about what backing store DRBD is using. Pacemaker is just told you have some DRBD resource, please manage it. So once we had that middle link in place, we could tell Pacemaker, start managing things on cluster 1 again. Pacemaker doesn't even know that the middle link exists. All it sees is some DRBD resource backing onto some block device. And so there's no problem with letting Pacemaker do its thing there because you're no longer making changes to the cluster.
Are you going to talk about how you tested this?
Yes, that's coming up next.
Go ahead, thanks.
Okay, so some gotchas we had to look out for. Silent corruption is actually very, very easy when you're, remember what I said about chaining DRBD resources together, you only care about the data moving in one direction. Because of that, anything that you write to the volume that's underlying DRBD on cluster 2 is not going to get replicated back to cluster 1. So when testing, you have to be very, very careful about what you write to. Because as soon as you write anything to that volume, DRBD is not going to know to resync it. It doesn't have a way of telling that somebody's gone outside its sphere of influence and written stuff onto that volume. The other...
Isn't the slave volume read-only?
Okay, so what I mean by the underlying volume is the device that you're saying use this to replicate to. So DRBD, I believe, won't expose a block device for the volume it's managing, but there's nothing stopping you taking DRBD down, writing data yourself to whatever volume DRBD is writing to, and then starting it up again, and it'll have no idea that you've done that. Manually editing the DRBD configuration, which is what you need to do in this case because it's not something you do often enough to be worthwhile trying to automate. So basically you have 2 clusters, a total of 4 nodes, and each one of them has a different DRBD config because not every one of them knows about all the DRBD resources that every other one does. So you kind of have to sanity check your config 3 or 4 times over to make sure that you have all the right ports and all the right backing volumes on all the right nodes, because it's easy to get confused when you're dealing with multiple different configs. So that's one big drawback of this method. Okay, for testing, I'm going to say it's desirable that writes done on the new cluster don't impact the consistency of the replicated data. The reason I say that it's desirable and not required is that technically you can write all you want to it and then just kick off another full sync, but that's going to take another couple of days or whatever, so you don't want to. What we did to test was leave the volume, which happened to be on LVM that DRBD was writing to well alone, snapshot that, and start up Pacona on the snapshot. And then, of course, once you're done testing Pacona and you know everything works, you just throw the snapshot away and your origin volume's untouched, and you know that it's not that it's consistent.
You didn't consider using the checksums to verify that it's either the same?
Well, DRBD is going to, yes, you could do that, but you'd have to.
As long as it's sync.
Sorry?
It takes just as long as it's sync.
No, it doesn't take as long as it's sync.
If you do a verify, that takes just as long as a sync.
Does it?
Yeah.
Okay. Yeah.
All right, the other thing I was going to mention with that is if you wanted to check the data outside of DRBD itself, you'd need to make sure that you got snapshots of the data that are consistent with each other at the same time, because you're having data constantly written to the volume. Whereas I think it's reasonable to assume that if you haven't written anything to to the origin LV that DRB is replicating to after you've done the initial sync, it's reasonable to assume that that's going to be consistent because the only thing that's ever written to it has been DRBD.
In addition to that, you could just choose some key data sets and just do a sanity check on those, because that will be quick to do rather than trying to check something.
Yeah, but so sorry, I've been forgetting to mention to repeat the questions. That was to say that you can just choose some key data sets to test. If you can mount the file system on the snapshot and start Pacona, then it's at least clear that you don't have any particularly obvious corruption in any case. And as I said, if nothing but DRBD has been writing to your volume, then it's quite unlikely that it's going to be corrupted unless you have disk issues or something along those lines. So we did come across a minor problem when testing, that we hadn't given the Pacona user the same UID on both nodes, so of course it didn't own its own files and couldn't start up. That's normally not worth mentioning, but I've given this its own slide because it illustrates the importance of testing this before cutting over, because if you did the cutover and just thought everything's going to be fine because I know I have a consistent data set, then it would take you the same length of time to track down and fix this problem, but you'd be doing it while Pacona was down. So testing is quite important. And we also did, I haven't made a slide about it because it's boring, but we also did do testing on an isolated cluster away from production before we made any changes on production so that we knew that the method was sound. So once we'd done all the testing and we were ready to cut over, first thing, of course, is to stop Pacona and unmount its file system so you no longer have anything writing to the DRBD resource. I like to check that both DRBD resources are in sync just because if something unexpected happens and you find that you have a few blocks out when you cut off the replication, then again you can get corruption, or at the very least out-of-datedness. So you bring down the intercluster resource on the new master. So to go back to where I had the nice diagram, in order to be able to start Pacona on cluster 2, you need to not have that DRBD link on top of it. You don't need to stop it on cluster 1 because cluster 1 is just going to realize the connection's gone and wait for it to come back, and it'll never come back, but we don't care once we've moved to cluster 2. I've gone too far. Okay, and then you can, so once you have that intercluster resource taken down on cluster 2, the cluster should now be in the state that Pacemaker wants it to be in. So you can turn off maintenance mode, tell Pacemaker, please start up Pacona, and everything should be hunky-dory. If it's not, you can roll back at that point. But as it turned out, everything was hunky-dory and went ahead. The total downtime Narjas reported for this procedure was 10 minutes. That is basically the time taken to restart Pacona with a data set that's huge. Because we kept the block device in sync the entire time, there was no final sync in the end. We stopped Pacona, unmount the file system, mount up the file system, and start it up again. So it's effectively just a failover between two clusters. You can't get a shorter downtime window without trying to do something like live migrate the Pacona process, which seems like an awful lot of effort for reducing an already fairly short downtime window. So we didn't pursue that option. After the cutover, you can re-enable Puppet, make sure Pacemaker is managing everything. If you have, we have reasonable monitoring for Pacemaker, so we can just look at Narjas and say, yes, Pacemaker seems good. Then you resize the file system so that it expands into the area previously used for the old cluster's metadata. So if you recall this diagram, that red metadata is no longer being used once you're off cluster 1. It's just been replicated across and forgotten about. So you just resize to FS that, and then it's like it never existed. Okay, looking at what this method gave us, it worked well for this specific use case due to the unusual constraints of a very large volume of data with enough I/O activity that we couldn't use Pacona's built-in replication. In fact, even if we had been able to use Pacona's built-in replication, it's worth noting that the downtime wouldn't have been reduced because you have to restart Pacona to enable binary logging anyway. So you just would have had that downtime a while before the cutover instead of at the cutover. An incremental rsync would actually take even longer because it has to read through all the files and make sure that nothing's changed, because Pacona stores its data in huge blobby files, as relational databases tend to do. And rsync doesn't know how to introspect those, it just treats them as binary. So what we achieved through this was 10 minutes of downtime for a 3 terabyte data set by syncing at the block level rather than the application or the file system level. I will say that for most use cases, this method is unnecessarily complex. Most of the time, you're going to be able to use something like Pacona replication or rsync or something along those lines, and doing a block level sync is just over the top. If you're using something that doesn't have its own replication built in, and for whatever reason you can't use rsync or some similar method, then this might be interesting to you. And just wanted to finish drawing some conclusions from our experiences with this. DRBD manages to be incredibly flexible due to the fact that it's designed to integrate into the Linux I/O stack. It's effectively a component like any other component like LVM or anything, and you can piece it together to do whatever you want. It makes it useful outside of HA clustering. It's mainly used for replication for high availability, but in this case we've used it as a data transport to get data from one place to another. But naturally every use case is going to be different, and that's one of the great things about the modularity of Unix in general, and DRBD just fits into that Unix philosophy that we all know and love. So there are some links. The first one is my employer, Anchor. We do managed hosting. And the second link is the DRBD Users Guide, which contains a lot of very useful information, and you can work out how to do a lot of cool things like this just from reading through the Users Guide. So I would recommend doing that if you use DRBD and haven't read through it. And that was all I had, and I appear to be about right on time. So are there any questions?
How long did the initial inter-cluster sync take then, while you had obviously both the original and the new underlying clusters?
It was around 2 or 3 days, I think. I don't remember the specifics, and I don't recall what it was bound by either. But we didn't want to just let it do its thing on the network unchecked, because the DRBD traffic between the clusters was using the same network link as the intra-cluster DRBD. So we didn't want to let the initial sync from one cluster to another go nuts and then slow down the traffic that we actually care about for production.
Yeah, worse yet, you can actually get it where it hangs if you do that kind of thing. If you start with bandwidth, good plan.
So we have a throttle then, the DRBD syncing to achieve that? How did you achieve
Yes, okay, sorry, I've been forgetting to repeat the questions again. The first question was how long the initial sync took. This newer question is if you're able to throttle the DRBD sync. I believe that's actually an option in the DRBD config, so you can set a default throttle so that it won't go nuts on you as soon as you start the sync, and you can also manually set it so you can raise or lower it or whatever for your needs later on. So it's built into DRBD that it can do that. Yeah?
As I appreciate the kind words you said about the stacking stuff that I wrote in there about 4 years ago, so glad it's still useful. I do have some concerns about the setup that you presented. If you have a 3 terabyte data set, and it takes you 10 minutes to gracefully shut it down, then I don't know your InnoDB transaction log or buffer pool settings, but I'm guessing that on an actual failover that is DRBD based, you're probably going to run through an InnoDB crash recovery that is much longer than that. So I don't know your SLA here, but if that takes you something like 30 or 45 minutes, that's probably not going to make your customers happy. Which is why I'm asking, did you at any point for this specific migration consider going to XDB cluster instead rather than PRM? Basically, cut over, like on your original cluster, on the secondary, install the XDB cluster binaries instead of the standard Pacona server binaries, cut over into that because they're binary compatible, and then add additional nodes to that cluster, including the ones that you bring up. Use an SST based on extra backup or whatever, so you don't block on that new master. Is that something that you considered?
Okay, so the question was if we considered moving to using XtraDB cluster rather than Pacona due to the 10-minute time it takes to shut down and start up Pacona. That's not something that we considered at the time, partly because we were approaching the capacity of the cluster fast enough that the objective was get it onto new machines with more storage, and XtraDB is not something we have a good deal of experience working with, so we wanted to go with something we knew worked. Yes, if we'd had a little bit more time when planning it, that might have been something we'd considered, but no. In this particular case, it's not something that we'd considered, no.
Have you run crash recovery tests on the new hardware since with that data set and specifically with that traffic to the site? In other words, do you know what your actual hard failover time is?
Okay, the question was if we know what the hard failover time is, if we've run tests on it. I haven't myself. I also didn't, after finishing this migration, I was working on other projects, so it's entirely possible that somebody else, whoever picked this up, has gone and done that, but personally I haven't myself, no. Yeah.
What was the underlying storage? Was an LVM logical volume?
Yes, LVM on top of. Yep. The question was, what's the underlying storage in LVM logical volume? Yes.
So how does DRB deal with that, having its underlying storage size resized? Is that something that is coped with?
In this particular case, the storage wasn't resized for a single DRBD resource. We had two differently sized resources. But yes, DRBD will let you resize the underlying storage, and then you just do a DRBD ADM resize to move the metadata to the new location.
Any more questions, guys? We've got a good 5 minutes. If anyone's got any more? Yep.
I'll throw in one that's half question, half statement. I noticed that you said that you tested all this on another cluster, and I went through some similar things before, and there's often a lot of pushback from the people who hold purse strings when you say, hey, we've got 2 clusters and I want you to spend the money on another 2 clusters so that I can properly test the whole thing. But we found that really invaluable, and so I was going to say, I'm glad you went that way, and I think that's something you should really push for as a technical person, otherwise you'll just end up wearing it all.
Okay, so I'll just repeat what was said. The comment was that it was a good idea to test on a separate cluster before doing this in production.
Well, more to the point that it's kind of a bit of an ask when you say, I want to replicate the cluster failover, because there's a lot of resources that you need. You need another set of storage systems, another set of...
I'll explain more clearly what I did. Effectively, because of what I wanted to test was this process, to make sure that the process itself was sane, without really caring about the specifics of the data being replicated. I just did that on a few throwaway VMs. So it was actually a fairly cheap process to spin up the VMs, install Pacona and DRBD and whatnot, and then try this out. So if it had been a more involved procedure where it made more of a difference what was being replicated, then yes, that would have been a bit more difficult to accomplish. But given that I could just do it on a few VMs, that was fairly straightforward.
Any
Any more questions? No? Okay, we'd like to thank Stephen on behalf of the RCA team.